So in this lecture, we'll learn about what is binary system, how to convert binary system into decimal systems or decimal system into binary systems. So before starting the binary system, let us talk about the decimal system that we normally use in our day-to-day life. The decimal system uses 10 different symbols to represent numbers, that is 0 to 9. The word decimal comes from the root word dec, which means 10. So now if I talk about the different numbers, 0 represents 0 objects or no objects. 1 represents 1 object, 2 represents 2 objects, 3 represents 3 objects, and so on till 9. To find out the value of these symbols, let's say if I want to find out the value of 4, then the value of 4 is 4 times 10 raised to power 0. Here we use the number 10 because this is a decimal system where we have 10 different symbols, hence we use 10. So if I multiply 4 times 10 raised to power 0, which is basically 1, so the value of this number is 4. Similarly for all these numbers till 9. Now if I want to go to the next number from 9, then I'll have to use these 10 symbols to represent a number which is next to the number 9. So we add one digit to the left. So the digit which is to the left should be greater than 0. Hence we cannot use 0, and out of these 9 digits we can use any of them on the left side. In this case, when we talk about 1, then this 1 and this 1 is not same. The value of this 1 is 1 times 10 raised to power 1, that is 1 into 10, which is basically 10. So here the 1 represents the value of 10. Similarly, if I move on to 45, let's say, then the value of this 4 is not only 4, but it is 4 times 10 raised to power 1, that is 40. And in this way we keep on going till 99. To have a number after 99, we need to add one more digit on the left hand side. So starting from the lowest digit, out of all these 9 digits we have 1. So we add 1 to the leftmost place. And so this value of 1 is basically 1 into 10 raised to power 2. So here if it is 1, then the value of this 1 is 1 into 100, that is 100. So the value of this 1 is 100. In the same way, if I come to this number 879, then in this case the value of this 8 is 8 into 100, that is 800, and so on like this. So as we keep on adding the number to the left hand side, the value of that number increases by multiple of 10. So now let us take some random example, 456. So the value of this 6 is 6 times 10 raised to power 0, which is nothing but 6, plus the value of this 5 is 5 times 10, that is 50. The value of this 4 is 4 times 100, that is 400. So the value of this number is 456. And in the same way, if we have another number on this side, then the value of that number will be 10 times the previous one. So in this case, in this way, as we keep on moving to the left hand side, the value of that number increases by multiples of 10. Now coming on to the binary system, it uses two different symbols, namely 0 and 1. The word binary comes from the root word bi, which means 2. So in this, we keep on using these two different numbers again and again to represent the consecutive next numbers. If I want to find out the value of this 1, then the value of this 1 is basically 1 times 2 to the power 0. So now why we are using 2 here? Because we are studying the binary system in which we use two different symbols. In the previous slide, we were talking about the decimal systems, and in the decimal systems we have 10 different symbols, so we multiply by a factor of 10. Here, since we have two different symbols, so we multiply by a factor of 2. Okay, so now here 1 times 2 to the power 0 is basically 1, so the value of this 1 is 1. Now if I want to find out the next number after this 1, then I'll have to add a number to the left hand side. Since the number that is added onto the left hand side should be greater than 0, so it cannot be 0, so it has to be 1. So all the binary numbers that we have in the starting, that is on the left hand side, extreme left hand side, will always have the number 1. So the next number would be starting with 1. So the value of this 1 and the value of this 1 is not same. The value of this 1 is basically 1 times 2 to the power 1, that is 1 into 2 is 2. So the value of this 1 is basically 2. In the same way, we keep on going to the next number, that is 1 1. After 1 1, there is no other 2-digit number in the binary system, so we add 1 to the left hand side again. Then we get these numbers. In this case, the number 1 is having a value of 1 times 2 to the power 2, which is shown here. So the value of this 1 is basically 4. In this way, we keep on going in the forward directions. As we keep on adding new numbers on the left hand side, the value of those numbers increases by multiple of 2. So now let's take an example. Let's take this as an example. So we have 1 0 0 1. As I said, the first digit, that is 1, will have a value of 1 times 2 to the power 0. So this is basically 1 into 1, plus 0 times anything is 0, same here, and then 1 time 2 to the power 3 is basically 8. So this adds up to 9. So this number represents 9. Okay, so this 1001 represents 9. One thing to note down here is that this number, we don't call it as 10, but it is 10. This is 1 1. This is 101. This is not 101. This is 101. So this is how we call in the binary systems. Now coming on to the conversions, the first conversion that we have is converting binary system into the decimal systems. Okay. So let's take the first example, 1 1 0 1. So here we write 1 1 0 1. So the value of this 1 is 1 times 2 to the power 0, which is 1. So now, just to make things simple, we can expand these numbers and we can make them like this. So 1 times 1 is 1, 0 times something is 0, 1 times 4 is 4, 1 times 8 is 8. So what we get is 8 plus 1 is 9, 9 plus 4 is 13. So the answer that we get is 13. Now in the same way, moving on to the next question, which is 1 0 1 1. So we have 1 0 1 1. So 1 times 1 is 1, plus 1 times 2 is 2, 0 times anything is 0, 1 times 8 is 8. So this is 8 plus 2 10, plus 1 11. So here the answer is 11. Now moving on to the next question, we have 1 0 0 0 1. So we have 1 0 0 0 1. So 1 times 1 is 1, 0 times anything is 0, so we have 0 plus 0 plus 0, plus 1 times 16 is 16. So 16 plus 1 is 17. So our answer is 17. In the same way, moving on to the next, we have 1 1 1 1. So here I can write 0 also, because if we add 0 onto the left hand side, there is no change in the value of the complete number. Let's say if I have 2, or if I write this as 02, it is same. If I have 108, if I write this as 0108, it doesn't matter. Okay, in the same way, if you add 0 onto the left hand side, it doesn't matter, the value remains the same. So we have 1 times 1, that is 1, 1 times 2 is 2, 4, 8, and here it is 0. So we get is 2 plus 8 is 10, that is 15. So the answer that we get is 15. I think it's very simple. So now let us find out the conversion of decimal system into binary system. So before starting, now let us give you very small information. If we divide 8 by 2, then the various terminologies that we have is, this 2 is known as the divisor, 8 is known as the dividend, this 4 is the quotient, and in the end what we get is known as the remainder. So this is something which you should know. Now let us start and find out the conversion of 8 decimals into binary. So let us divide 8 by 2. So we get the quotient 4 minus 8, 0. So the remainder that we get is 0. I will write that remainder here. Now we got here the quotient 4. We again divide this 4 by 2. We get 2 here, we get 4 here, and we get 0. So the remainder is 0. I will write on the side. So now here we got 2. Again we'll use that. Again we'll divide that 2 by 2. So we get 1 minus 2, that is 0. So we got the remainder here 0. In the end you will always get 1 as the quotient. So you write that 1 in the end. So now the answer of this would be 1, 0, 0, 0. So 8 to the base 10 is equal to 1, 0, 0, 0 to the base 2. So now I will again repeat this. If you have any number which we want to convert into the binary system, then divide that 8 by 2. Whatever remainder that we get, write that remainder on the side, and whatever quotient that we get, divide that quotient by 2 again. So here we divide 4 by 2, we get the remainder 0. We write that remainder on the right hand side. Now we'll again divide this 2 by 2, we get the remainder as 0. So we'll write that remainder on the right hand side, and in the end we'll always get this 1 as quotient. So we'll put that quotient 1 in the below at the bottommost. The answer would be in the vertical direction, that is 1, 0, 0 and 0. Okay, 25 to the base 10 is how much in binary? Let us take 25, divide by 2. So instead of doing the division differently, we will do the division in the same line. So I know it is very simple. If I divide 25 by 2, then I will get the quotient as 12 and the remainder would be 1. Please remember that whenever you have an odd number, okay, and you are dividing it by 2, there will always be 1 as a remainder. Okay, now this 12 you have to again divide it by 2, you will get 6. Since 12 is an even number, remainder would be 0. Now this 6 has to be again divided by 2, we get 3 and the remainder would be 0 since 6 is an even number. I divide 3 by 2, I get 1. Since 3 is an odd number, I would get a remainder of 1. Now this 1 is there in the end, so I'll put this 1 and 1 in the end, just like that. So the answer is this, that is 1, 1, 0, 0, 1. So 25 to the base 10 is equal to 1, 1, 0, 0, 1 to the base 2. Now let's move on to the next question. Here we have 9. So 9 divided by 2, we get the quotient as 4. Since this is an odd number, we'll get a remainder of 1. 4 divided by 2, we will get quotient as 2. Since 4 is an even number, remainder would be 0. 2 divided by 2, we will get quotient as 1. Since 2 is an even number, the remainder would be 0, and this 1 would come here in the end. Our answer would be 1, 0, 0, 1. So 9 is equal to 1, 0, 0, 1 to the base 2. So now let's say if I want to check whether this is correct or not. So if I check this 1, 0, 1. So I know that this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2, this is 2 to the power 3. So this is 1 into 1 plus 0 plus 0 plus 2 to the power 3 is 8. Our answer is 9, and this is 9. So our answer is correct. So if you want, you can check also. But I would say that please do not waste your time on checking back. You should do this calculation very nicely. So if you have some good practice, you will be able to get the answer absolutely correct. Next question is 55. Since the number is big, so we'll have a bigger calculation. So the table will be very long. 2 divided by 55, it will be 27. 27. So since 55 is an odd number, this will be, remainder would be 1. I again divide 27 by 2. I will get 13. Since this is a odd number, remainder would be 1. This would be 6. Since 13 is a odd number, remainder would be 1. I divide 6 by 2. I get quotient as 3. Since 6 is an even number, remainder would be 0. Quotient would be 1. 3 is odd, remainder would be 1. And this 1 would again come here. So the answer would be 1, 1, 0, 1, 1, 1. So 55 is equal to 1, 1, 0, 1, 1, 1. So this is our answer.